How you going, guys? Curtis from Cutting Edge Engineering. Today's job, we're going to continue on with the project of manufacturing our boom lift cylinders for our 14-ton Frenner crane. So we've already machined the rods and the barrels and got them welded. Today we're going to continue with getting everything else machined, but what I'm going to do first is get the rod eyes bored to size. So we've got our first rod set up in the mill. We're going to be boring out the eye to 2.5 inches, and that is going to suit a standard bush that would be available off the shelf from a parts supplier. Even though we are making our own bushings for it, I still like to make things standard. That way, if I ever sell this crane, someone can just go buy parts off the shelf and replace them. Righto, so we've got our first eyed board to size. It came out pretty good. So we're going to get this one out of the mill, get the other one set up and get it up to the same stage. So now we've got all that done, we're going to get on to machining up the bushes that go in the end of the cylinder rod into the eyes. What we're going to be using is LG2 bronze. It is 70mm OD, 35 ID and about 110mm long. So we do have to machine every surface on those in order to bring them to size to suit what we're doing. But I couldn't get anything that was closer to the dimensions that I needed. So this is what we have to do. .6mm. Righto, now that we've got both bushes machined to length and bored to size, I'm going to set them up on a mandrel. I'm going to be using a cone center and the tailstock to hold them into the chuck, and I can turn the OD to size. And we'll be giving these a 0.1 interference fit into the cylinder rod eyes, so the measurement we're shooting for is 63.6 mil. Righto, so I've got all the lathe work done on our two bronze bushes, really happy with how they turned out. What I need to do next is I need to machine a groove into the cast iron bearing that supports the rod and goes underneath the gland nut. And I'm going to do that because running cast iron on chrome cylinder rod is old technology. We don't really do that anymore. We use a polymer or a plastic wear band in order to keep the two parts separated. So unfortunately my sandblaster didn't really want to work today. I think it got pretty wet. All of the media inside is clumped together. So I can't sandblast all of my parts until I clean all that out. But I don't have time for that today, so I'm just going to give these a quick wire wheel, clean them up, give them a quick inspection, then we can get on to machining the groove for the wear bands. That'll work. Yeah, I think so. Happy with that. It's like that's a sleeve. Heaps of room. moisture coming out of it. Righto, so I've machined that out to size to suit our new wear band, but we do have a bit of an unusual line running around the inside. It actually looks like there is a sleeve in there, but I haven't been able to find the other end of it, and I haven't been able to really upset it to the point where it's come out. And after inspecting the other bearing, I can't find it there either. So I'm not exactly sure what it is or how it's been done. So what I need to determine now is whether these are even usable or I need to go to the effort to make new ones. I'm not 100% sure on how these were put together, so I do want to do a little bit more investigation. What I'm going to do is I'm going to take the bearing out, turn it around, and I'm going to skim the bottom side of it and see if I can find a join. Depending on what I find will depend whether we use them.
I don't get it.
Right, so I've skimmed that and I didn't actually find anything. I can't find a join where there would be a sleeve, everything machined really nicely the whole way. Because there is no hydraulic pressure physically against this, it bypasses through the channel on the side. I don't believe whatever's in there is going to find its way out. So I'm pretty confident in using these. So this one's done, we'll get it out of the lathe and get the other one finished. Oh, alright, I figured it out. Righto, so I did figure it out. After I blew a bit of air at it, I actually found oil coming through this corner. So what it looks like it is, they are two parts and they have pressed this top piece into the other half of it and then machined it all to size. Because this is all encapsulated in the top of the cylinder by the gland nut, there is no way this is going to get loose and do any damage, so I'm confident in using them. Now that they're done, the last thing I need to do is machine up the 4 new pins. So we have 2 different sizes. 2 of the pins are going to be 2 inches in diameter and 2 of the pins will end up being 52 mil in diameter. 52 mil is not a size that is available off the shelf, so we have had to buy 55 mil and it will need to be turned down. The 2-inch pins will connect the cylinder rods up to the boom, and the 52 mil pins will connect the barrels down to the chassis of the crane. So we're going to get started on the 2-inch pins. I need to face each end and drill and tap a hole in the end of it. That hole will be used to fixture the light onto the machine, or it can be used as a pull rod to pull the pin out if we ever need to remove the cylinders again. Now with the 2-inch pins done, we can get started on our 52mm pins, but because they're starting out at 55mm, we're going to have to turn down the entire diameter. After we're finished with them in the lathe, we'll have to take them over to the milling machine and drill 2 holes in the end of the pin for the retaining plate that holds it onto the frame of the crane. Now with those holes drilled, I also need to drill holes through our bronze bushes, which will be for the grease. Now with all that done, there's one more thing I need to do, and that is tap the holes in the cylinder eyes for the grease nipples, which will feed grease into the bushes.
Oh. Sit.
Pig's ears.
Sit. Spin around. Lay down. Roll over. Oh, good boy. Up, jump, jump, jump. Make a mess. Oh my God.
Righto, so now I'm going to press the centering sleeves out of the old bearings because we are going to be reusing them. We can then give them a clean up and we're going to press them into our new bearings. You're dead. So with all of that completed, now we can start putting the cylinders back together. First thing I'm going to do is press our bronze bush into the cylinder rod eye.
Ooh.
Okay. Ah, for sake, forgot about the stock collar. Righto guys, so we thought we would answer a few of the comments we got on the last couple of videos about this project and rebuilding the cylinders. A lot of people were concerned that we had bought a lemon and we had created ourselves a bit of a money pit. The thing is, we knew what we were getting into when we bought this project and what most of the repairs would be and how much they would cost. The great thing is I can do all of the repairs myself, so I'm not paying someone else to do it. Once all the repairs are done, we will only be in it for less than half of the cost of what a similar capacity crane would be in the same condition. So we will give a breakdown of the cost of the repairs as we go through the project. These cylinders weren't available off the shelf, and if they were, they would have been astronomically expensive, where at the moment I've only got a couple of $1,000s invested into these, plus a bit of my time which I'm willing to put into it. So a few also commented, why don't we just change out the 2 cylinders to a larger single cylinder? And there's a few reasons for that. One of those is I already had the glands and the pistons and all of the parts for these 2 cylinders, where if I'd gone to make a bigger one, I would have to make new glands, new pistons, and the cost of material would be nearly 3 times the price of just rebuilding the original one. Not only that, I would have to reconfigure the design of the ends of the cylinders or the mounts on the machine in order to accommodate a larger cylinder. These 2 cylinders at the moment can lift well and properly more than 14 tons, so there is no purpose in putting a bigger one in there. The machine's hydraulic power at the moment can already lift the back of the crane off the ground if you pick up something too heavy. So I don't need any more lifting power. These 2 cylinders are more than enough. After seeing all the damage to the cylinders and the chrome work, I did take oil samples from a few areas around the hydraulic system. So I did take some from the tank, what we removed out of some of the cylinders, and the steering circuit. And the reason for that is I was concerned there was metal debris through the entire system. So I've taken those samples, sent them away, and we're waiting on the results back for that. Now with both cylinders assembled, I'm going to install new hydraulic fittings, cap them off, and prep these for paint. Way easier than a screwdriver. Check me out.
Hang on, what the hell's that?
You're running low. It's coming back. was hoping he was going to land, but unfortunately not today. Righto guys, so the weather's taken a turn for the worst. I was trying to get these painted today, but unfortunately it has started to rain. You can't paint in wet weather, so we're going to put this off for a couple of days and try and finish it then. So it's been a couple of days, the weather has fined up enough that we can actually finish painting our cylinders. That should be enough. That's it. Righto guys, so we've got our cylinders painted. I'm really happy with how they turned out. So we're going to let those cure for a couple of days, then I can refit the pipework and the new hydraulic hoses, but I won't be fitting them back to the crane until I get the test results from our oil samples. Once we've got those results, we'll then know if there's any more work that I need to do to the hydraulic system. So keep your eye out for the next video. Thanks for watching.
You have to be a crab. Go on. And because you're wearing this shirt, it's perfect.
I can't hear the Zoid.
Ah, that was great.
Hey going guys, Curtis from Cutting Edge Engineering. Today's job we're going to continue on. Hey going guys, Curtis from Cutting Edge Engineering. Today we're going to continue on with our project of... Hey going guys, Curtis from Cutting Edge Engineering. Today's job we're going to continue... bit my fucking tongue. So now what I need to do is determine whether these are even usable. That's a word? Yeah. Now with those holes drilled, I just need to drill... Oh fuck, how'd you say that?
I also need to.
Oh, I also said. Right, now with those holes drilled... Oh, wait, what? What did you say? Now with those holes drilled, I now need to grease... Is that right? Righto guys, so... Oh fuck, it's glary as fuck. Ready?
Yep.
I'm really squinty. Fuck, it's really
Oh
squinty.
my god, do you want to wait for the clouds?
I fucking
Ah,
do,
my
see?
eyes.
See?
Is that right, or do you put it on the inside lip? When you do it on the inside lip?
Uh-huh.
Perfect ratio.
Perfect. Spot on, Bevan. Jesus.
What? So, oh, are you actually going to do ratios?
Yeah, well, I was told don't thin this any more than about 10%.
Oh.
So, he's the paint guy. I'm gonna listen. Gouging rod.
Oh man.
Hey, one day I'm gonna have all the bits. Painting's a messy subject.
It's a painful subject when Curtis is involved.
I'm good.
Oh my goodness, hang on, there's probably a letter. Just hold on. Hey?